The universe is vast, mysterious, and filled with secrets that defy our understanding. What if I told you that out there, in the endless expanse of space, there are phenomena so strange, so baffling, that even the brightest minds on Earth can't fully explain them? From eerie signals that seem to come from intelligent beings to cosmic structures that challenge everything we know about physics, the cosmos is a treasure trove of enigmas waiting to be unraveled. Today, we're diving into 25 of the most mind-bending space anomalies that continue to puzzle scientists and stargazers alike. And at the heart of it all lies one of the most iconic mysteries, the WOW signal, a fleeting radio burst that has sparked decades of debate and wonder. Could it be a message from an alien civilization, or is it something even stranger? Buckle up, because by the end of this journey, you'll see the universe in a whole new light, and you might just find yourself questioning what's really out there. Let's begin. Now, let's turn our attention to one of the most famous and enduring mysteries in the history of space exploration, the WOW signal. It all began on a quiet summer night in 1977, when a radio telescope at Ohio State University's Big Ear Observatory picked up something extraordinary. For 72 seconds, a powerful, narrowband radio signal burst through the silence of space, so intense that it stood out like a beacon against the cosmic background noise. The signal was so remarkable that astronomer Jerry Amon, who discovered it, circled the data on the printout and wrote a single word next to it: WOW. Giving the signal its iconic name. What made the WOW signal so special? For starters, it matched the expected characteristics of a potential extraterrestrial transmission. It was a strong, focused signal at a frequency of 1,420 MHz, a range often considered ideal for interstellar communication because it's relatively free of interference from natural cosmic sources. But just as quickly as it appeared, the signal vanished, never to be detected again despite numerous attempts to find it. This fleeting nature has only deepened the mystery. Was it a message from an advanced alien civilization, a cosmic flare, or something else entirely? The WOW signal's origin remains one of the greatest unsolved puzzles in astronomy, sparking debates and inspiring countless theories. Some scientists suggest it could have been a natural phenomenon, like a passing comet reflecting radio waves, while others argue that its precision and intensity point to an intelligent source. Whatever the truth, the WOW signal continues to captivate our imagination, reminding us that the universe is full of surprises waiting to be uncovered. As we explore more of these cosmic anomalies, keep the WOW signal in mind. It's a perfect example of how even a single, fleeting moment in the vastness of space can leave us questioning everything we think we know. Now let's dive deeper into the theories and debates surrounding the WOW signal. Since its discovery, scientists have proposed a range of explanations, each with its own set of arguments and challenges. One of the most discussed natural explanations involves comets. In 2017, astronomer Antonio Paris suggested that the signal might have been caused by the hydrogen clouds surrounding two comets, known as Comet 266P/Christensen and Comet P/2008Y2, which were passing through the region of space where the signal originated at the time. These comets emit hydrogen, which could have produced a radio signal at the same frequency as the WOW signal. However, this theory has faced criticism, as the comets were not in the exact location of the signal when it was detected, leaving room for doubt. On the other hand, the possibility of extraterrestrial communication continues to capture the imagination of both scientists and the public. The signal's narrowband frequency, its intensity, and its brief, one-time appearance all align with what we might expect from an intentional transmission from an advanced civilization. Supporters of this theory argue that the WOW signal's precision and uniqueness make it difficult to explain through natural phenomena alone. Yet, skeptics point out that without a repeat detection, it's impossible to confirm whether the signal was truly artificial or just a rare cosmic coincidence. The debate doesn't end there. Some researchers have proposed other natural explanations, such as a burst of energy from a distant star or an unusual interaction between cosmic particles. Each theory has its merits, but none have been able to fully account for all the characteristics of the WOW signal. This lack of consensus has kept the mystery alive, fueling ongoing research and speculation. Scientists continue to scan the skies, hoping to detect a similar signal that could provide more clues. What makes the WOW signal so fascinating is not just the question of its origin, but what it represents. It's a reminder of how much we still don't know about the universe and the tantalizing possibility that we might not be alone. As we move forward, the WOW signal remains a symbol of both our curiosity and our limitations in understanding the cosmos. And with that, let's turn our attention to another intriguing anomaly. The Black Knight satellite, a mysterious object orbiting Earth that has sparked its own share of theories and debates. Now, shifting our gaze closer to home, we encounter one of the most enigmatic objects ever rumored to orbit our planet, the Black Knight satellite. This mysterious entity has captured the imagination of conspiracy theorists and space enthusiasts alike, sparking debates about its origins and purpose. The story of the Black Knight satellite dates back to the late 1950s, when unusual radio signals were reportedly detected by both amateur and professional astronomers. These signals were said to originate from an unknown object orbiting Earth, leading to speculation that it could be an artificial satellite of extraterrestrial origin. The name Black Knight was later popularized in the 1970s when images from early space missions appeared to show a dark, unidentified object in orbit. Some claimed it was an ancient alien probe, possibly thousands of years old, sent to observe Earth. Others suggested it could be a relic from a lost human civilization or even a secret military project. The most famous image associated with the Black Knight satellite comes from a 1998 space shuttle mission, where a dark, irregularly shaped object was photographed against the backdrop of space. While NASA later identified it as a thermal blanket lost during a spacewalk, the image only fueled further speculation. Conspiracy theories about the Black Knight satellite often point to its alleged connection to Nikola Tesla, who claimed to have intercepted strange radio signals in the early 20th century. Some believe these signals were transmissions from the satellite, suggesting it has been monitoring Earth for over a century. Despite these claims, mainstream scientists remain skeptical, attributing the phenomenon to space debris, natural cosmic noise, or even misinterpretations of data. Yet, the allure of the Black Knight satellite persists, symbolizing humanity's fascination with the unknown and the possibility of extraterrestrial contact. What makes the Black Knight satellite so compelling is not just the mystery of its existence, but the questions it raises about our place in the universe. Could it be evidence of advanced civilizations watching us from the shadows of space? Or is it simply a case of cosmic coincidence and human imagination running wild? As we continue to explore the cosmos, the Black Knight satellite remains a tantalizing enigma, reminding us that even in our own backyard, the universe holds secrets we have yet to uncover. With that, let's turn our attention to another cosmic oddity, Oumuamua, the interstellar visitor that left scientists scratching their heads. Now, let's journey beyond our solar system to explore one of the most puzzling visitors from the depths of space, Oumuamua. Discovered in October 2017 by astronomers using the Pan-STARRS telescope in Hawaii, this interstellar object became the first known visitor from another star system to pass through our cosmic neighborhood. Its name, Oumuamua, means scout or messenger from afar in Hawaiian, a fitting title for an object that has sparked endless curiosity and debate. What makes Oumuamua so extraordinary is its unusual shape and behavior. Unlike most asteroids or comets, which are typically round or irregularly shaped, Oumuamua appeared to be elongated, resembling a cigar or a pancake. Estimates suggest it could be up to 10 times longer than it is wide, a shape rarely seen in natural space objects. Adding to the mystery, Oumuamua exhibited unexpected acceleration as it traveled through our solar system. While comets often speed up due to outgassing, the release of gases as they warm up, Oumuamua showed no visible signs of a coma or tail, the usual indicators of such activity. This peculiar behavior led some scientists to propose extraordinary explanations. Could Oumuamua be an alien spacecraft, perhaps a solar sail or a probe sent by an advanced civilization? The idea gained traction when researchers noted that its acceleration and trajectory seemed too precise to be entirely natural. Harvard astronomer Avi Loeb famously suggested that Oumuamua might be a piece of alien technology, a theory that ignited both excitement and skepticism within the scientific community. However, not everyone is convinced. Many astronomers argue that Oumuamua's oddities can be explained by natural phenomena. For instance, its acceleration could be the result of hydrogen outgassing, a process that wouldn't leave visible traces. Others propose that Oumuamua might be a fragment of a larger object, torn apart by gravitational forces or a collision, which could account for its unusual shape. Despite these theories, the lack of definitive data has left the true nature of Oumuamua unresolved. What's fascinating about Oumuamua is not just the mystery of its origin, but what it represents. As the first known interstellar object to visit our solar system, it challenges our understanding of the cosmos and raises profound questions. Are there more objects like Oumuamua drifting through space? Could some of them indeed be artificial, sent by civilizations far beyond our reach? Or is Oumuamua simply a natural oddity, a reminder of how much we still have to learn about the universe? As we ponder these questions, Oumuamua serves as a tantalizing glimpse into the vast, uncharted territories of interstellar space. Its brief visit has left an indelible mark on astronomy, inspiring both wonder and debate. And with that, we turn our attention to another cosmic enigma, Tabby star, a celestial body whose strange dimming patterns have baffled scientists and stargazers alike. Now, shifting our gaze to another cosmic puzzle, we arrive at Tabby star, officially known as KIC 8462852. This distant star, located roughly 1,400 light-years away in the constellation Cygnus, has captured the attention of astronomers and space enthusiasts alike due to its bizarre and unpredictable dimming patterns. Unlike most stars which dim in regular, predictable cycles, Tabby's star experiences dramatic and irregular drops in brightness, sometimes by as much as 22%. These fluctuations are so unusual that they defy conventional explanations, sparking a wave of speculation and scientific inquiry. The mystery of Tabby's star began in 2015 when citizen scientists participating in the Planet Hunters project flagged its strange behavior. Named after astronomer Tabetha Boyajian, who led the initial study, the star's erratic dimming patterns quickly became a hot topic in the astronomical community. One of the most intriguing theories proposed to explain these anomalies is the idea of a Dyson sphere, a hypothetical megastructure built by an advanced alien civilization to harness the star's energy. According to this theory, the irregular dimming could be caused by massive structures orbiting the star, partially blocking its light as they pass in front of it. While the idea of alien megastructures is undeniably captivating, scientists have also explored more natural explanations. One possibility is that Tabby's star is surrounded by a massive cloud of dust and debris, perhaps the remnants of a shattered planet or comet. This debris could periodically obscure the star's light, creating the observed dimming patterns. Another theory suggests that the star itself might be undergoing internal changes, such as magnetic activity or stellar pulsations, which could cause its brightness to fluctuate unpredictably. Despite extensive observations and studies, the true nature of Tabby's star remains elusive. What makes this anomaly so fascinating is not just the mystery itself, but what it represents for our understanding of the universe. Could it be evidence of advanced extraterrestrial technology, or is it simply a natural phenomenon we have yet to fully comprehend? Either way, Tabby's star challenges our assumptions and reminds us of the vast, uncharted mysteries that lie beyond our solar system. As we continue to explore the cosmos, Tabby's star stands as a testament to the enduring allure of the unknown. Its strange behavior invites us to question, to wonder, and to seek answers in the infinite expanse of space. And with that, we turn our attention to another enigmatic phenomenon: fast radio bursts, mysterious signals from deep space that have puzzled scientists for decades. Now, let's dive into another cosmic enigma that has left scientists scratching their heads: fast radio bursts, or FRB. These are incredibly powerful bursts of radio waves that last just milliseconds but pack as much energy as the sun emits in an entire day. First detected in 2007, FRBs originate from deep space, often billions of light years away, making them one of the most mysterious phenomena in the universe. What makes FRBs so puzzling is their unpredictability. Most of these bursts are one-off events, appearing once and never repeating, while a handful have been observed to repeat at irregular intervals. This inconsistency has made it incredibly difficult for astronomers to pinpoint their origins. Are they the result of cataclysmic events, like the collision of neutron stars or the collapse of massive stars into black holes? Or could they be signals from advanced extraterrestrial civilizations, as some have speculated? The possibilities are as vast as the cosmos itself. One of the most famous repeating FRBs, known as FRB 121102, was discovered in 2016. This particular burst has been observed repeating multiple times, giving scientists a rare opportunity to study its behavior. Despite this, its source remains a mystery. Some theories suggest it could be coming from a highly magnetized neutron star, or magnetar, while others propose it might be linked to exotic objects like cosmic strings or even black holes. Adding to the intrigue, some FRBs appear to originate from regions of space that seem empty, with no visible galaxies or other celestial objects nearby. This has led to even more questions about what could be producing these bursts. Could they be the result of unknown astrophysical processes, or are we witnessing something entirely new and unprecedented? The study of FRBs is still in its early stages, but advancements in technology, like the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, are helping scientists detect and analyze these bursts with greater precision. Each new discovery brings us closer to understanding these cosmic flashes, but for now, they remain one of the most tantalizing mysteries in modern astronomy. As we ponder the origins of fast radio bursts, we're reminded once again of how much we have yet to learn about the universe. These fleeting signals from the depths of space challenge our understanding and ignite our curiosity, urging us to keep exploring. And with that, we turn our attention to another profound question: why, despite the vastness of the cosmos, have we not yet found definitive evidence of extraterrestrial life? This brings us to the Fermi Paradox, a topic that ties together many of the anomalies we've explored so far. Shifting our gaze from the fleeting flashes of fast radio bursts, we now confront one of the most profound questions in astronomy: the Fermi Paradox. Named after physicist Enrico Fermi, this paradox highlights a striking contradiction. Given the vastness of the universe and the high probability of life-sustaining planets, why haven't we encountered any signs of extraterrestrial civilizations? It's a question that ties directly into the anomalies we've explored so far, from the WOW signal to the mysterious FRBs. The Fermi Paradox begins with a simple observation. Our galaxy alone contains hundreds of billions of stars, many of which are orbited by planets in the so-called habitable zone, where conditions might support life. With such an immense number of potential homes for life, It seems almost inevitable that intelligent civilizations should exist. Yet, despite decades of searching, we've found no definitive evidence of their existence. This absence of contact is what makes the paradox so puzzling. One possible explanation is that intelligent life is incredibly rare. Perhaps the conditions required for complex life to evolve are so specific that Earth is a cosmic anomaly. Another theory suggests that advanced civilizations might self-destruct before they can develop the technology to communicate across interstellar distances. Nuclear war, climate change, or other catastrophic events could wipe out civilizations before they ever make contact with others. On the other hand, some scientists propose that intelligent life might be out there, but we simply haven't detected it yet. The universe is unimaginably vast, and our current methods of searching for extraterrestrial signals are limited. It's possible that alien civilizations are using communication methods we haven't even imagined, or that they're deliberately avoiding contact with us. This idea ties back to anomalies like the WOW signal and FRBs. Could these be attempts at communication that we're just not equipped to understand? Another intriguing possibility is that advanced civilizations might be so far beyond our comprehension that their existence is effectively invisible to us. They could have transcended physical forms, moved to other dimensions, or developed technologies that render them undetectable by our current instruments. This concept, often referred to as the zoo hypothesis, suggests that we might be living in a kind of cosmic preserve, observed but not interfered with by more advanced beings. The Fermi Paradox doesn't just challenge our understanding of extraterrestrial life, it also forces us to reflect on our place in the universe. Are we truly alone, or is the cosmos teeming with life that we're simply unable to perceive? As we continue to explore anomalies like the WOW signal, FRB, and others, the search for answers to this paradox remains one of the most compelling quests in science. With this in mind, let's turn our attention to another gravitational mystery that pulls galaxies toward it, the Great Attractor. This cosmic anomaly raises even more questions about the forces shaping our universe. Now let's journey deeper into the cosmos to uncover another gravitational enigma, the Great Attractor. This mysterious force, hidden in the depths of space, exerts an irresistible pull on galaxies, including our own Milky Way. But what exactly is the Great Attractor, and why does it remain one of the most perplexing anomalies in modern astronomy? The Great Attractor is a region of space located approximately 250 million light-years away, in the direction of the constellations Centaurus and Hydra. It's not a single object, but rather a massive concentration of matter, so dense that its gravitational influence can tug entire galaxies toward it. Imagine a cosmic magnet, invisible yet powerful enough to shape the motion of galaxies across vast distances. This is the Great Attractor. One of the biggest challenges in studying this anomaly is its location. The Great Attractor lies in what astronomers call the zone of avoidance, an area of the sky obscured by the dense dust and stars of our own galaxy's plane. This makes it incredibly difficult to observe directly, as much of the light and radiation from this region is blocked by the Milky Way. It's like trying to peer through a thick fog. Only glimpses of the truth can be seen. Despite these obstacles, scientists have pieced together some clues about the Great Attractor's nature. Observations suggest that it contains a massive cluster of galaxies, along with vast amounts of dark matter, which amplifies its gravitational pull. This combination of visible and invisible matter creates a gravitational well so deep that it influences the motion of galaxies across hundreds of millions of light-years. Our Milky Way, along with the local group of galaxies, is being drawn toward it at a staggering speed of over 600 kilometers per second. But the Great Attractor isn't the end of the story. Beyond it lies an even larger structure known as the Shapley supercluster, which may be contributing to the gravitational pull we experience. This raises intriguing questions about the interconnected nature of cosmic structures and how they shape the universe on the grandest scales. The mystery of the Great Attractor also ties into broader questions about the distribution of matter in the universe. Why does matter clump together in such extreme concentrations? What role does dark matter play in these cosmic structures? And could there be even greater anomalies lurking in the unseen reaches of space? As we continue to explore the Great Attractor and its surroundings, we're reminded of how much remains hidden from our view. This gravitational anomaly challenges our understanding of the universe and pushes the boundaries of what we can observe. It's a reminder that the cosmos is full of secrets waiting to be uncovered. With this gravitational puzzle in mind, let's turn our attention to another mysterious phenomenon, dark flow. This strange movement of galaxy clusters hints at forces beyond our current understanding, raising even more questions about the nature of the universe. Now, shifting our gaze to another cosmic mystery, let's explore the phenomenon known as dark flow. This strange and unexplained movement of galaxy clusters has left scientists scratching their heads as it hints at forces that lie far beyond the edges of our observable universe. What could be causing entire clusters of galaxies to move in unison, as if pulled by some unseen hand? Dark flow was first discovered in 2008, when astronomers noticed that galaxy clusters were drifting in a specific direction at speeds of up to 1,000 kilometers per second. This motion couldn't be explained by the known distribution of matter in the universe, including the gravitational influence of the Great Attractor or even the Shapley supercluster. It was as if something massive and invisible, far beyond what we can see, was tugging on these clusters. One of the leading theories suggests that dark flow might be caused by structures outside our observable universe. Imagine the universe as a vast ocean and our observable universe as a small island. Beyond the horizon, there could be other islands, massive concentrations of matter exerting a gravitational pull on everything within our view. These unseen structures, if they exist, could be remnants from the early universe, regions where matter clumped together in ways we can't yet comprehend. Another possibility is that dark flow is a result of the universe's expansion. As space itself stretches, it might carry galaxy clusters along with it in a specific direction. However, this explanation doesn't fully account for the uniformity and speed of the movement observed. It's a puzzle that challenges our understanding of cosmology and raises questions about what lies beyond the limits of our observations. The implications of dark flow are profound. If it's caused by structures outside our observable universe, it could mean that the cosmos is far larger and more complex than we've ever imagined. It might even hint at the existence of other universes, part of a multiverse that extends far beyond our own. Alternatively, it could point to new physics, forces, or phenomena that we haven't yet discovered. Despite the tantalizing possibilities, dark flow remains a controversial topic. Some scientists argue that the observations could be the result of measurement errors or other local effects. However, the consistency of the data across multiple studies suggests that there's something real and significant at play. It's a mystery that continues to inspire research and debate, pushing the boundaries of our knowledge. As we ponder the enigma of dark flow, we're reminded once again of how much we still have to learn about the universe. This mysterious movement of galaxy clusters challenges our assumptions and opens up new avenues for exploration. It's a reminder that the cosmos is full of surprises waiting for us to uncover them. With this in mind, let's turn our attention to another cosmic oddity, the Boötes Void. This vast, empty region of space stands in stark contrast to the crowded galaxy clusters we've just discussed, offering yet another puzzle for astronomers to solve. Now, let's journey into one of the most puzzling regions of the cosmos, the Boötes Void. Imagine a space so empty, so vast, that it defies our understanding of how the universe is structured. This enormous region, spanning an area of about 330 million light-years across, is one of the largest known voids in the universe. To put that into perspective, if our Milky Way galaxy were placed inside the Boötes Void, its nearest neighbor would be millions of light years away. It's a cosmic desert, a place where galaxies are few and far between, standing in stark contrast to the crowded clusters we've explored earlier. The Boötes Void was first discovered in the 1980s, and its existence immediately raised questions. Why is this region so empty? How did it form? And what does it tell us about the universe's structure? One of the leading theories suggests that the void is a result of the universe's large-scale structure. After the Big Bang, matter wasn't distributed evenly. Instead, it clumped together in some areas, leaving others nearly empty. Over billions of years, these empty regions expanded, creating voids like the one in Boötes. Another intriguing possibility is that the Boötes Void might be the result of cosmic collisions or interactions between galaxies. As galaxies moved and merged, they could have cleared out vast regions of space, leaving behind these enormous voids. However, this explanation doesn't fully account for the sheer size of the Boötes Void. It's so large that even the most dramatic galactic interactions would struggle to explain its emptiness. Some scientists have even speculated that the Boötes Void could be evidence of something more exotic, like the influence of dark energy or other unknown forces. Dark energy, which drives the accelerated expansion of the universe, might play a role in shaping these voids. Alternatively, the void could be a window into the early universe, a remnant of conditions that existed shortly after the Big Bang. If that's the case, studying the Boötes Void could help us understand the universe's origins and evolution. Despite its emptiness, the Boötes Void isn't completely devoid of galaxies. A handful of galaxies have been found scattered throughout this vast expanse, like isolated islands in an endless ocean. These galaxies are of particular interest to astronomers because they might hold clues about how galaxies form and evolve in such extreme environments. Studying them could reveal new insights into the processes that shape the universe. The Boötes Void challenges our understanding of the cosmos. It's a reminder that the universe isn't just a collection of stars and galaxies, it's a complex, dynamic system with regions of incredible density and others of profound emptiness. As we continue to explore this cosmic desert, we're left with more questions than answers. What other secrets does the Boötes Void hold, and what can it teach us about the universe's grand design? With this mystery in mind, let's turn our attention to another anomaly that has puzzled scientists for decades, the Pioneer Anomaly. This unexpected behavior of the Pioneer spacecraft has sparked debates and inspired new theories about the forces at work in our solar system. Now, shifting our gaze closer to home, we encounter the Pioneer Anomaly, a mystery that has baffled scientists since the 1970s. The Pioneer 10 and Pioneer 11 spacecraft, launched in the early 1970s to explore the outer reaches of our solar system, began exhibiting behavior that no one could have predicted. As these spacecraft traveled farther from Earth, they started to slow down slightly more than expected. This tiny but consistent deceleration, though seemingly insignificant, sparked a wave of curiosity and debate among scientists. At first, the anomaly was dismissed as a minor glitch or an error in measurement. But as the data continued to pour in, it became clear that something unusual was happening. The spacecraft were experiencing a force that couldn't be explained by the known laws of physics. This unexpected deceleration, amounting to just a fraction of a millimeter per second squared, might sound trivial, but in the precise world of space exploration, even the smallest discrepancies can lead to groundbreaking discoveries. Scientists scrambled to find an explanation. Could it be the result of a technical issue, like a fuel leak or an instrument malfunction? Detailed analysis ruled out these possibilities. The spacecraft were functioning as intended, and the anomaly persisted. This led researchers to consider more exotic explanations. One theory suggested that the deceleration might be caused by the spacecraft's heat emissions. As the Pioneers generated heat, it radiated outward, potentially creating a tiny but measurable force that slowed them down. While this explanation seemed plausible, it didn't fully account for the observed effect. Another intriguing possibility was that the Pioneer Anomaly might be evidence of new physics forces or phenomena that we haven't yet discovered. Some scientists speculated that it could be related to dark matter or dark energy, the mysterious substances that make up most of the universe. Others proposed modifications to Einstein's theory of general relativity, suggesting that our understanding of gravity might need to be updated. These ideas, while exciting, remain unproven, leaving the Pioneer Anomaly as one of the most enduring puzzles in space exploration. Despite decades of research, the true cause of the Pioneer Anomaly remains elusive. However, the mystery has inspired new missions and technologies designed to study similar effects in greater detail. For example, the New Horizons spacecraft, which flew past Pluto in 2015, carries instruments that could help shed light on this phenomenon. By carefully tracking its trajectory, scientists hope to uncover clues that might explain the Pioneer Anomaly once and for all. The Pioneer Anomaly serves as a reminder that even in the well-studied environment of our solar system, there are still mysteries waiting to be solved. It challenges us to question our assumptions and pushes the boundaries of our understanding. As we continue to explore the cosmos, anomalies like this remind us that the universe is full of surprises, and every discovery brings us closer to unraveling its secrets. With this in mind, let's turn our attention to another cosmic enigma, the cosmic microwave background cold spot. This unusual feature in the afterglow of the Big Bang has sparked its own set of questions and theories, offering yet another glimpse into the mysteries of the universe. Moving deeper into the mysteries of the cosmos, we now encounter the cosmic microwave background cold spot, a peculiar feature in the afterglow of the Big Bang that has left scientists both puzzled and intrigued. The cosmic microwave background, or CMB, is the faint radiation left over from the early universe, often referred to as the echo of the Big Bang. It provides a snapshot of the universe when it was just 380,000 years old, offering invaluable insights into its origins and evolution. However, within this ancient light lies an anomaly, a region significantly colder than its surroundings, known as the cold spot. Discovered in 2004 by the Wilkinson Microwave Anisotropy Probe, the cold spot spans an area of the sky about 5 degrees across, roughly 10 times the diameter of the full moon. At first glance, such a feature might seem like a minor irregularity, but its existence challenges our understanding of the universe. According to the standard model of cosmology, the CMB should be relatively uniform, with only small fluctuations in temperature. The cold spot, however, is far colder than what this model predicts, raising questions about its origin. One leading explanation suggests that the cold spot might be the result of a cosmic void, a vast, underdense region of space containing fewer galaxies and matter than expected. If light passes through such a void, it loses energy due to the expansion of the universe, a phenomenon known as the integrated Sachs-Wolfe effect. This could explain why the cold spot appears colder than its surroundings. However, studies have shown that the void required to produce such a significant temperature drop would need to be extraordinarily large, far exceeding the size of any known voids in the universe. Another intriguing possibility is that the cold spot could be evidence of a collision between our universe and another, bubble universe, in a multiverse scenario. This collision, if it occurred, might have left an imprint on the CMB, creating the cold spot as a kind of cosmic bruise. While this idea is speculative, it highlights the potential for the cold spot to reveal entirely new physics, challenging our understanding of the universe on a fundamental level. Despite these theories, the true nature of the cold spot remains unresolved. Some scientists argue that it could simply be a statistical fluke, a rare but natural variation in the CMB. However, the odds of such a large and cold region appearing by chance are estimated to be less than 1 in 50, making this explanation less likely. Others suggest that our current models of the universe might be incomplete, and the cold spot could be pointing us toward new physics or phenomena we have yet to discover. The cold spot serves as a reminder that even our most advanced models of the universe are not infallible. It challenges us to rethink our assumptions and explore new possibilities, pushing the boundaries of our knowledge. As we continue to study this enigmatic feature, it may hold the key to unlocking deeper truths about the cosmos, from the nature of dark energy to the existence of parallel universes. With this in mind, let's turn our attention to another fascinating anomaly, the Moon's transient lunar phenomena. These mysterious flashes and glows observed on the lunar surface have sparked their own set of questions, offering yet another intriguing puzzle in our exploration of the universe. Shifting our gaze from the vast expanse of the cosmic microwave background to our closest celestial neighbor, we now delve into the Moon's transient lunar phenomena. These mysterious flashes and glows observed on the lunar surface have puzzled astronomers and skywatchers for centuries. Unlike the steady, unchanging face of the Moon we often see, these fleeting events suggest a more dynamic and enigmatic world than we might expect. Transient lunar phenomena, or TLP, refer to short-lived changes in brightness, color, or appearance on the Moon's surface. These events can last anywhere from a few seconds to several hours and have been reported by both amateur astronomers and professional observatories. Some describe them as sudden flashes of light, while others note patches of glowing or dimming areas. Despite their elusive nature, these phenomena have been documented for hundreds of years, with records dating back to the 18th century. One of the most widely accepted explanations for TLP involves outgassing, the release of gases trapped beneath the Moon's surface. As the Moon's crust shifts or fractures, these gases might escape, creating brief bursts of light or glowing patches. This theory is supported by the fact that many TLP events occur near the edges of lunar maria, the dark, flat plains formed by ancient volcanic activity. These regions are thought to contain pockets of residual gas, making them prime locations for such activity. Another possibility is that TLP could be caused by meteoroid impact. When a small space rock collides with the Moon, it can create a bright flash as it vaporizes upon impact. These flashes are often visible from Earth, especially during meteor showers when the Moon passes through dense streams of debris. However, not all TLP events align with known meteoroid activity, suggesting that impacts alone cannot explain every occurrence. Some researchers have proposed more exotic explanations, such as electrostatic phenomena. The Moon's surface is exposed to intense solar radiation, which can cause dust particles to become electrically charged. Under certain conditions, these charged particles might produce faint glows or sparks, contributing to TLP. While this idea is intriguing, it remains speculative as no direct evidence has been found to confirm it. Perhaps the most controversial theory is that TLP could be linked to lunar tectonics. Although the Moon is often considered geologically inactive, recent studies suggest that it might still experience small-scale seismic activity. If true, this could trigger the release of gases or dust, leading to the observed phenomena. However, this theory is still in its early stages, and more data is needed to fully understand its implications. Despite decades of observation, the true cause of transient lunar phenomena remains a mystery. Some scientists argue that TLP might not have a single explanation, but could instead result from a combination of factors, including outgassing, impacts, and electrostatic activity. Others believe that these events could point to entirely new processes at work on the Moon, processes we have yet to discover. The study of TLP not only deepens our understanding of the Moon, but also highlights the dynamic nature of seemingly inert celestial bodies. It reminds us that even our closest cosmic companion holds secrets waiting to be uncovered. As we continue to explore the Moon, both through telescopes and future missions, these transient flashes and glows may reveal new insights into its history and geology. With this in mind, let's turn our attention to another enigmatic feature, the infamous face on Mars. This peculiar formation has sparked debates and fueled imaginations, offering yet another intriguing puzzle in our journey through the cosmos. Now, as we leave the Moon behind, our journey takes us to the red planet Mars, where one of the most iconic and debated anomalies in space exploration awaits, the infamous face on Mars. This peculiar formation has captured the imagination of scientists, conspiracy theorists, and the public alike, sparking decades of speculation about its origins and meaning. The story of the Mars face begins in 1976, when NASA Viking 1 orbiter captured an image of a region on Mars known as Cydonia. In this image, a formation resembling a human face appeared to stare back at us from the Martian surface. The initial photograph, taken from a distance, showed what looked like a symmetrical face with eyes, a nose, and a mouth, leading to widespread fascination and debate. Was this a natural rock formation, or could it be evidence of an ancient alien civilization? Scientists quickly pointed out that the face was likely the result of pareidolia, a psychological phenomenon where the human brain perceives familiar patterns like faces in random shapes. This explanation seemed plausible, especially when higher-resolution images taken by later missions, such as Mars Global Surveyor in the late 1990s, revealed that the formation looked much less face-like up close. The new images showed a heavily eroded mesa, a flat-topped hill, with features that appeared more jagged and less symmetrical than the original Viking image suggested. However, not everyone was convinced. Some argued that the later images were taken under different lighting conditions, which could obscure the face-like appearance. They also pointed to other nearby formations in Cydonia, such as pyramid-like structures, as potential evidence of artificial construction. These claims fueled theories that the face on Mars could be a relic of an ancient Martian civilization, perhaps even a monument built by intelligent beings. To explore this further, researchers have analyzed the geological context of the Cydonia region. The area is characterized by a mix of mesas, valleys, and impact craters, all shaped by natural processes like erosion and tectonic activity. The face itself is part of a larger group of formations that, while striking, can be explained by these same processes. For example, the mesa's symmetrical appearance could be the result of wind and water erosion over millions of years, combined with the angle at which the original image was taken. Despite the scientific consensus that the face on Mars is a natural formation, the debate continues to captivate the public. The idea of an ancient alien civilization on Mars taps into our fascination with the unknown and our desire to find evidence of life beyond Earth. It also raises important questions about how we interpret images and data from other worlds, and the role of human perception in shaping our understanding of the cosmos. As we reflect on the Mars face, it serves as a reminder of the power of curiosity and the importance of critical thinking. While the allure of ancient alien monuments is undeniably exciting, the scientific process encourages us to seek evidence-based explanations even when they challenge our imaginations. The face on Mars may not be a monument to extraterrestrial life, but it remains a symbol of humanity's enduring quest to explore and understand the mysteries of the universe. With this intriguing anomaly behind us, let's turn our attention to another marvel of our solar system, the hexagonal storm on Saturn's North Pole, a phenomenon as mesmerizing as it is mysterious. Now, shifting our gaze from the dusty plains of Mars, we arrive at the breathtaking beauty of Saturn, where a phenomenon unlike anything else in our solar system awaits: the enigmatic hexagonal storm at its North Pole. This six-sided jet stream, first discovered by the Voyager missions in the early 1980s, has puzzled scientists for decades with its precise geometric shape and enduring stability. The Saturn hexagon is a massive storm spanning approximately 30,000 kilometers in diameter, large enough to fit nearly 4 Earths side by side. Its most striking feature is its near-perfect hexagonal shape, with each side measuring roughly 13,800 kilometers in length. This geometric precision is unlike any other weather pattern observed in the solar system, making it a subject of intense scientific curiosity. One of the most fascinating aspects of the hexagon is its longevity. Unlike Earth's hurricanes, which typically last for days or weeks, this storm has persisted for decades, possibly even centuries. The hexagon's stability raises questions about the forces that sustain it, especially given Saturn's turbulent atmosphere, which is dominated by swirling clouds and powerful winds. Scientists have proposed several theories to explain the hexagon's formation. One leading hypothesis suggests that the storm's shape is the result of atmospheric waves interacting with Saturn's rapid rotation. Saturn spins on its axis once every 10 hours and 33 minutes, creating strong jet streams that flow eastward at its north pole. These jet streams, combined with the planet's internal heat and atmospheric dynamics, may generate the hexagonal pattern as a natural consequence of fluid dynamics. Another theory points to the role of deep-seated convection currents within Saturn's atmosphere. These currents, driven by the planet's internal heat, could create a stable, rotating vortex that maintains the hexagon's shape over time. Computer simulations have shown that similar hexagonal patterns can form under specific conditions, supporting the idea that the storm is a product of Saturn's unique atmospheric environment. Despite these advances, the hexagon remains a mystery in many ways. For instance, why does it maintain such a precise shape over such a long period? And why is it confined to Saturn's north pole, with no similar structure observed at the south pole? These questions continue to drive research, with missions like NASA Cassini spacecraft providing invaluable data. Cassini's observations revealed intricate details about the hexagon structure, including its towering cloud walls and the complex interactions between its winds and surrounding atmosphere. The hexagon also offers a window into the broader dynamics of gas giants. By studying this phenomenon, scientists hope to gain insights into the atmospheric processes that shape not only Saturn but also other planets with similar characteristics, such as Jupiter and Uranus. The hexagon's unique properties make it a natural laboratory for understanding the behavior of fluids and gases under extreme conditions. As we marvel at the Saturn hexagon, it serves as a reminder of the wonders that await us in the cosmos. Its precise geometry and enduring presence challenge our understanding of planetary atmospheres and inspire us to explore further. With each new discovery, we come closer to unraveling the mysteries of our solar system and the forces that shape it. Turning our attention now to the next anomaly, we venture into the depths of space to explore the Red Rectangle Nebula, a celestial object as intriguing as it is beautiful. Now, as we leave the geometric marvel of Saturn's hexagon behind, our journey takes us to a cosmic masterpiece that seems almost too perfect to be natural: the Red Rectangle Nebula. This striking celestial object, located approximately 2,300 light-years away in the constellation Monoceros, is one of the most visually stunning and scientifically puzzling nebulae in the universe. Its name comes from its distinct rectangular shape and deep red hue, a combination that has captivated astronomers and stargazers alike. The Red Rectangle Nebula is classified as a protoplanetary nebula, a transitional phase in the life cycle of a star. It occurs when a dying star, similar to our Sun, sheds its outer layers, creating a glowing shell of gas and dust. What makes this nebula stand out, however, is its unusual symmetry and vibrant colors. Unlike the chaotic, irregular shapes of many other nebulae, the Red Rectangle appears almost artificially precise, with its rectangular structure and intricate ladder-like patterns of glowing gas. The nebula's vivid red color is primarily due to the presence of hydrogen gas, which emits a characteristic red glow when energized by the central star. Surrounding this red core are bands of blue and green, created by the scattering of light from dust particles. This interplay of colors and shapes gives the Red Rectangle a surreal, almost artistic quality, making it a favorite subject for both scientific study and astrophotography. But what truly baffles scientists is the nebula's unique geometry. Most nebulae form irregular, cloud-like structures, but the red rectangle's near-perfect symmetry suggests a highly organized process at work. One leading theory proposes that the rectangular shape is the result of a dense disk of dust and gas surrounding the central star. As the star ejects material, this disk funnels the outflow into two opposing cones, creating the distinctive X-shaped structure seen in the nebula. Over time, these cones appear to us as a rectangle due to our viewing angle. Another mystery lies in the nebula's central star system. Observations have revealed that the red rectangle is not powered by a single star but by a binary system, two stars orbiting each other in a tight dance. This binary interaction may play a crucial role in shaping the nebula's structure, as the gravitational forces between the stars could influence the outflow of material. However, the exact mechanisms behind this process remain unclear, leaving scientists with more questions than answers. The red rectangle also offers a glimpse into the future of our own solar system. In about 5 billion years, our Sun will undergo a similar transformation, shedding its outer layers to form a planetary nebula. By studying objects like the red rectangle, astronomers hope to better understand the processes that govern the final stages of a star's life and the intricate structures that can emerge during this phase. Despite decades of research, the red rectangle nebula continues to defy easy explanation. Its precise geometry, vibrant colors, and complex formation process make it a fascinating subject for both professional astronomers and amateur stargazers. As we marvel at its beauty, we are reminded of the countless mysteries that still await us in the cosmos, each one a testament to the universe's endless capacity to surprise and inspire. With a red rectangle nebula leaving us in awe, our exploration of unexplained space anomalies now takes us to the heart of our galaxy, where another enigma awaits the galactic center anomaly. As we venture deeper into the mysteries of the cosmos, our attention now turns to the very heart of our galaxy, where an extraordinary anomaly lies hidden, the galactic center anomaly. Nestled within the dense core of the Milky Way, this region is a hotbed of strange signals, intense energy emissions, and phenomena that challenge our understanding of the universe. At the center of it all lies Sagittarius, a star, a supermassive black hole with a mass equivalent to 4 million suns, around which the entire galaxy revolves. The galactic center anomaly is a treasure trove of cosmic oddities. One of the most perplexing features is the presence of mysterious radio waves and X-ray emissions that seem to defy conventional explanations. These signals, detected by powerful telescopes, fluctuate in intensity and pattern, leaving scientists puzzled about their origins. Some theories suggest they could be the result of interactions between the supermassive black hole and surrounding matter, while others propose the existence of exotic objects or even unknown physical processes at play. Adding to the intrigue are the so-called G-objects, strange celestial bodies that orbit close to Sagittarius, a star. These objects appear to be a hybrid between stars and gas clouds, exhibiting behaviors that don't fit neatly into either category. At times, they stretch and distort as they approach the black hole, only to reform afterward, as if defying the laws of physics. Their true nature remains a mystery, sparking debates about whether they are remnants of stellar collisions or entirely new classes of cosmic entities. Another fascinating aspect of the galactic center anomaly is the presence of massive magnetic fields. These fields, far stronger than those found elsewhere in the galaxy, twist and warp the space around them, influencing the movement of stars and gas. Scientists believe these magnetic fields could play a key role in shaping the dynamics of the galactic core, but their exact origins and effects are still poorly understood. Perhaps the most dramatic phenomenon associated with the galactic center anomaly is the occasional flaring activity of Sagittarius, a star. These flares, which can increase the black hole's brightness by hundreds of times in mere minutes, are thought to be caused by the sudden infall of matter. However, the exact mechanisms behind these eruptions remain unclear, raising questions about what triggers them and how they influence the surrounding environment. The study of the galactic center anomaly is not just about unraveling the mysteries of our galaxy's core, it's also a window into the fundamental forces that govern the universe. By observing this region, astronomers hope to gain insights into the behavior of supermassive black holes, the nature of dark matter, and the processes that drive galactic evolution. Yet, for every answer we uncover, new questions arise, reminding us of the boundless complexity of the cosmos. As we leave the enigmatic heart of our galaxy behind, our journey through unexplained space anomalies continues, leading us to another cosmic puzzle, the enduring mystery of the WOW signal, which we'll revisit with fresh perspectives and discoveries. Now, as we circle back to one of the most iconic mysteries in the history of space exploration, we revisit the WOW signal, a fleeting yet profound event that continues to captivate scientists and enthusiasts alike. Discovered in 1977 by astronomer Jerry Amon, this 72-second burst of radio waves stood out not just for its intensity, but for its striking resemblance to the kind of signal we might expect from an intelligent extraterrestrial source. The name itself, WOW, comes from Amon's handwritten note on the data printout, a spontaneous expression of awe that has since become synonymous with the search for cosmic intelligence. What makes the WOW signal so intriguing is its specificity. It was detected at a frequency of 1,420 MHz, a range known as the hydrogen line, which is considered a prime candidate for interstellar communication due to its universal significance in the study of hydrogen, the most abundant element in the universe. The signal's narrow bandwidth and precise frequency further fueled speculation that it could be artificial in origin. Yet, despite decades of searching, no repeat signal has ever been detected, leaving its true nature shrouded in mystery. Modern astronomy has brought new tools and perspectives to the table, but the WOW signal remains as enigmatic as ever. Some researchers have proposed natural explanations, such as the possibility of a passing comet emitting radio waves, though this theory has been met with skepticism. Others suggest it could have been a one-time event, like a distant star undergoing a rare and dramatic transformation. Still, the idea that it might have been a deliberate attempt at communication from an advanced civilization lingers, tantalizing our imaginations and driving the search for extraterrestrial intelligence or SETI forward. What's fascinating is how the WOW signal connects to other anomalies we've explored. Like the fast radio bursts and the strange signals from the galactic center, it represents a fleeting glimpse into the unknown, a reminder that the universe is full of phenomena we don't yet understand. These anomalies challenge us to think beyond conventional explanations and consider the possibility of entirely new cosmic processes or even intelligent life beyond Earth. The enduring mystery of the WOW signal also highlights the limitations of our current technology. While our telescopes and instruments have grown more powerful, they still struggle to capture and analyze transient events with the precision needed to solve such puzzles. This has spurred innovations in observational techniques, such as the development of arrays capable of scanning vast swaths of the sky in real time, in hopes of catching another signal like it. As we reflect on the WOW signal, it's clear that its significance extends far beyond a single unexplained event. It represents humanity's enduring curiosity and our relentless drive to explore the unknown. Whether it was a message from another civilization, a natural cosmic event, or something entirely beyond our current understanding, the WOW signal continues to inspire us to look to the stars and ask, are we alone? With this mystery still echoing in our minds, we now turn our attention to another profound enigma, the elusive nature of dark matter, a substance that makes up most of the universe's mass yet remains invisible to our instruments. What secrets does it hold, and how might it reshape our understanding of the cosmos? Let's find out. Now, shifting our gaze to one of the most profound mysteries in modern physics, we delve into the enigma of dark matter. Unlike the wow signal, which was a fleeting event, dark matter is a pervasive and invisible presence that shapes the very fabric of our universe. It's estimated that dark matter makes up about 85% of all matter in the cosmos, yet it doesn't emit, absorb, or reflect light, making it impossible to observe directly with our current technology. This invisible substance reveals itself only through its gravitational effects, bending light and influencing the motion of galaxies in ways that defy explanation based on the matter we can see. The story of dark matter begins with the observations of astronomer Fritz Zwicky in the 1930s. While studying the Coma cluster of galaxies, Zwicky noticed that the galaxies were moving far faster than expected based on the visible mass of the cluster. He proposed the existence of dunkel materie, or dark matter, to account for this discrepancy. Decades later, Vera Rubin's groundbreaking work on galaxy rotation curves provided further evidence. She found that stars at the edges of galaxies were orbiting just as fast as those near the center, a phenomenon that could only be explained if there was a massive, unseen halo of dark matter surrounding each galaxy. Despite its overwhelming presence, dark matter's true nature remains one of the greatest unsolved problems in physics. Scientists have proposed numerous theories to explain it, ranging from weakly interacting massive particles, or WIMP, to actions hypothetical particles that could account for its elusive properties. Experiments like the Large Hadron Collider and underground detectors such as Xenon and LUX have been searching for these particles, but so far, no definitive evidence has been found. This lack of detection has led some researchers to consider alternative explanations, such as modifications to the laws of gravity, though these ideas remain controversial. What makes dark matter so fascinating is its role in the universe's structure. Without it, galaxies as we know them wouldn't exist. It acts as a cosmic scaffold, providing the gravitational pull needed to gather ordinary matter into stars, galaxies, and clusters. Yet, its invisibility means we can only infer its presence indirectly through its gravitational influence on the visible universe. This has led to a tantalizing question. Could dark matter be part of a larger, hidden reality that we're only beginning to glimpse? The mystery of dark matter also connects to other anomalies we've explored. Like the wow signal and fast radio bursts, it challenges our understanding of the cosmos and pushes the boundaries of science. It reminds us that the universe is far more complex than we can currently comprehend, filled with phenomena that defy easy explanation. As we continue to search for answers, dark matter stands as a testament to the enduring mysteries of the cosmos and our relentless drive to uncover them. With this invisible enigma still lingering in our thoughts, we now turn to another cosmic puzzle: dark energy, the mysterious force driving the accelerated expansion of the universe. What is it and how does it shape the fate of everything we know? Let's explore. Now, as we venture deeper into the cosmic unknown, we encounter another profound mystery: dark energy. Unlike dark matter, which pulls galaxies together through gravity, dark energy is the mysterious force driving the universe apart at an accelerating rate. Discovered in the late 1990s through observations of distant supernova, dark energy has since become one of the most puzzling phenomena in modern cosmology. It's estimated to make up about 68% of the universe's total energy content, yet its true nature remains elusive. The story of dark energy begins with a surprising observation. Astronomers studying Type 1a supernova, which serve as cosmic mile markers, noticed that these explosions were fainter than expected. This suggested that the universe wasn't just expanding, it was doing so at an ever-increasing pace. This discovery turned our understanding of the cosmos on its head. Instead of gravity slowing down the expansion, as scientists had assumed, something was pushing it faster. That something is what we now call dark energy. One of the leading explanations for dark energy is the cosmological constant, a concept first introduced by Albert Einstein. Originally proposed to balance the equations of general relativity and maintain a static universe, the cosmological constant was later abandoned when the universe's expansion was discovered. However, with the revelation of accelerated expansion, the idea has made a comeback. The cosmological constant suggests that empty space itself possesses energy which drives the universe apart. Yet, this explanation raises new questions. Why does this energy have the exact value it does, and why is it so finely tuned to allow the universe we observe? Another possibility is that dark energy is not constant but changes over time. Some theories propose a dynamic form of energy, often referred to as quintessence, which could vary in strength and influence the universe's expansion differently at various points in its history. However, like the cosmological constant, quintessence remains purely theoretical, with no direct evidence to confirm its existence. The challenges in understanding dark energy are immense. Unlike dark matter, which interacts gravitationally with visible matter, dark energy doesn't seem to interact with anything in a detectable way. It doesn't clump together like matter. Instead, it permeates space uniformly, making it even harder to study. Current efforts to unravel its secrets include large-scale surveys like the Dark Energy Survey and the upcoming Euclid Space Telescope, which aim to map the universe's expansion in unprecedented detail. These projects hope to provide clues about whether dark energy is constant or evolving, and perhaps even reveal its true nature. Dark energy's implications are staggering. If it continues to accelerate the universe's expansion, it could lead to a future where galaxies are so far apart that they become invisible to one another, isolating civilizations and leaving the cosmos cold and dark. On the other hand, if dark energy changes over time, it could alter the fate of the universe in ways we can't yet predict. This mysterious force connects to many of the anomalies we've explored, from the wow signal to dark matter. Like them, dark energy challenges our understanding of the universe and reminds us how much we have yet to learn. It's a testament to the enduring mysteries of the cosmos and our relentless quest to uncover them. As we continue to probe the depths of space, dark energy stands as one of the greatest puzzles of all, a force that shapes the universe's destiny while remaining just out of reach. With this enigmatic force still on our minds, we now turn our attention to the Kuiper Belt, a region of the solar system filled with strange objects and phenomena. What secrets does this distant frontier hold, and how does it connect to the larger mysteries of the cosmos? Let's find out. Now, shifting our gaze closer to home, we arrive at the Kuiper Belt, a vast region of icy bodies and dwarf planets orbiting beyond Neptune. This distant frontier of our solar system is a treasure trove of cosmic oddities, offering clues to the early days of planetary formation and the forces that shaped our celestial neighborhood. Among its many mysteries, the Kuiper Belt is home to objects with orbits that defy expectations, raising questions about the history and dynamics of our solar system. One of the most intriguing inhabitants of the Kuiper Belt is Pluto, the dwarf planet that once held the title of the ninth planet. Pluto's orbit is highly elliptical and tilted compared to the relatively flat plane of the solar system, a feature shared by many other Kuiper Belt objects. This unusual alignment suggests that something significant happened in the early solar system, possibly a gravitational interaction with a massive object or even a passing star. Some scientists speculate that a yet undiscovered planet, often referred to as Planet 9, could be influencing these orbits from the outer reaches of the Kuiper Belt. Another fascinating object is Haumea, a dwarf planet with a unique, elongated shape and a rapid rotation that causes it to spin end over end like a football. Haumea's unusual characteristics, along with its family of smaller objects sharing similar orbits, hint at a violent collision in the distant past. This event not only shaped Haumea but also scattered debris across the Kuiper Belt, leaving behind a trail of clues for astronomers to piece together. Then there's Eris, a dwarf planet slightly more massive than Pluto, whose discovery in 2005 reignited the debate over what defines a planet. Eris's highly eccentric orbit takes it far beyond the main Kuiper belt, into a region known as the scattered disk. This area is populated by objects that have been flung outward by gravitational interactions, possibly with Neptune or other large bodies. The presence of these scattered objects challenges our understanding of how the solar system's outer regions evolved. Perhaps the most puzzling aspect of the Kuiper belt is the clustering of certain objects' orbits. Some of these icy bodies share similar orbital characteristics, suggesting they may have been influenced by a common force. This has led to the hypothesis of Planet 9, a hypothetical world several times the mass of Earth, lurking in the distant reaches of the solar system. While no direct evidence of Planet 9 has been found, its gravitational signature could explain the strange alignments observed in the Kuiper belt. The Kuiper belt is more than just a collection of icy debris. It's a window into the early solar system. By studying its anomalies, scientists hope to uncover the processes that shape the planets and the forces that continue to influence their movements. Each discovery adds a piece to the puzzle, bringing us closer to understanding the complex history of our cosmic backyard. As we leave the Kuiper belt behind, our journey takes us even farther into the depths of space to the Oort cloud. This distant, icy shell surrounds the solar system and is thought to be the source of long-period comets. What secrets does this remote region hold, and how does it connect to the larger mysteries of the cosmos? Let's find out. Now, as we venture even farther into the depths of space, we encounter the Oort cloud, a vast and mysterious shell of icy objects that envelops our solar system. Unlike the Kuiper belt, which lies relatively close to the planets, the Oort cloud is so distant that it marks the very edge of the Sun's gravitational influence. This remote region is believed to be the birthplace of long-period comets, those spectacular visitors that occasionally streak across our skies, leaving trails of wonder and curiosity. The Oort cloud is thought to extend up to 100,000 times farther from the Sun than Earth, making it one of the most challenging areas to study. Its immense distance means that no spacecraft has ever come close to exploring it directly. Instead, scientists rely on indirect evidence such as the trajectories of comets to piece together its structure and composition. These icy bodies, when nudged by gravitational forces, can be sent hurtling toward the inner solar system, offering us fleeting glimpses of the Oort cloud's hidden treasures. One of the most intriguing aspects of the Oort cloud is its role as a cosmic time capsule. The objects within it are believed to be remnants from the early days of the solar system, preserved in a deep freeze for billions of years. Studying these icy fragments could provide invaluable insights into the conditions that existed when the planets were forming. However, the sheer distance and faintness of these objects make them incredibly difficult to observe, even with the most advanced telescopes. Another mystery surrounding the Oort cloud is its origin. Some scientists propose that it formed from debris left over after the planets coalesced, while others suggest that it may contain material captured from other star systems during the Sun's early travels through the galaxy. This idea raises fascinating questions about the interconnectedness of stellar neighborhoods and the possibility that our solar system holds relics from distant stars. Despite the challenges, the Oort cloud continues to captivate astronomers. Its existence helps explain the origins of comets and provides a framework for understanding the outer limits of our solar system. Yet, much about this distant region remains unknown. What other secrets does it hold? Could it contain objects that challenge our current understanding of the solar system's history? As we continue to explore, the Oort cloud reminds us that even in the farthest reaches of space, there are still mysteries waiting to be uncovered. With the Oort cloud behind us, our journey now takes us to the Andromeda Galaxy, our closest galactic neighbor. What strange phenomena await us in this vast spiral of stars, and how do they connect to the larger mysteries of the universe? Let's find out. Shifting our gaze beyond the boundaries of our own galaxy, we arrive at the Andromeda Galaxy, a cosmic neighbor that holds its own share of mysteries. As the closest spiral galaxy to the Milky Way, Andromeda has long fascinated astronomers, not only for its beauty but also for the strange phenomena observed within its vast expanse. One of the most striking discoveries is the galaxy's peculiar motion. It's hurtling toward us at an astonishing speed of about 110 kilometers per second. This means that in roughly 4 billion years, Andromeda and the Milky Way are destined to collide, merging into a single, colossal galaxy. But what does this cosmic dance mean for the future of our galactic home? The impending collision raises intriguing questions. While the idea of two galaxies colliding might sound catastrophic, the reality is far less dramatic. The vast distances between stars mean that direct collisions are unlikely. Instead, the galaxies will pass through each other, their gravitational forces reshaping their structures over billions of years. The result will be a new hybrid galaxy, often referred to as Milkomda or Milkdromda. This event will transform the night sky, creating a dazzling display of stars and gas clouds unlike anything we've ever seen. But beyond the spectacle, what secrets might this merger reveal about the evolution of galaxies? Adding to the intrigue are the unusual observations made within Andromeda itself. Astronomers have detected strange patterns in the galaxy's rotation, with stars and gas clouds moving in ways that defy expectations. Some regions appear to rotate faster than predicted, while others show signs of turbulence and instability. These anomalies have led scientists to speculate about the presence of unseen forces, such as dark matter, influencing Andromeda's behavior. Could these observations provide clues about the nature of dark matter and its role in shaping galaxies? Another mystery lies in Andromeda's core. At its heart lies a supermassive black hole, much like the one at the center of the Milky Way. However, Andromeda's black hole appears to be unusually quiet, emitting far less radiation than expected. This has puzzled researchers who are trying to understand why such a massive object would remain so dormant. Some theories suggest that the black hole might be in a phase of inactivity, while others propose that it could be surrounded by a dense cloud of gas and dust obscuring its emissions. Whatever the reason, the quiet nature of Andromeda's black hole adds another layer of mystery to this already enigmatic galaxy. As we continue to study Andromeda, we're reminded of how much we still have to learn about the universe. Its collision course with the Milky Way offers a glimpse into the dynamic and ever-changing nature of galaxies, while its internal anomalies challenge our understanding of cosmic forces. What other surprises might Andromeda hold, and how will its eventual merger with the Milky Way reshape our understanding of the cosmos? As we ponder these questions, our journey through the mysteries of space continues, leading us to the next anomaly on our list. Now, let's turn our attention to a phenomenon that sounds almost like something out of a cosmic horror story: galactic cannibalism. This is the process by which larger galaxies, driven by their immense gravitational pull, consume smaller neighboring galaxies. It's a violent yet fascinating aspect of cosmic evolution that has shaped the universe as we know it. Imagine a galaxy billions of times more massive than our own, slowly devouring a smaller companion, tearing it apart over millions or even billions of years. This isn't just science fiction, it's a reality observed throughout the cosmos. Galactic cannibalism occurs when a larger galaxy's gravity overwhelms a smaller one, pulling it into its orbit. Over time, the smaller galaxy is stretched and distorted, its stars and gas clouds absorbed into the larger galaxy. This process doesn't happen overnight. It's a slow, relentless dance that can take eons to complete. One of the most famous examples is the Milky Way itself, which is currently in the process of absorbing several smaller galaxies, including the Sagittarius dwarf spheroidal galaxy. This ongoing event leaves behind streams of stars like cosmic breadcrumbs, tracing the path of the smaller galaxy's destruction. But why does this matter? Galactic cannibalism isn't just a spectacle, it's a key driver of cosmic evolution. When a larger galaxy consumes a smaller one, it gains new stars, gas, and dust, which can fuel the formation of new stars and planets. This process also triggers intense bursts of star formation, known as starbursts, as the influx of material compresses and ignites within the larger galaxy. Over time, these mergers can transform the structure of galaxies, turning spiral galaxies into elliptical ones or creating entirely new hybrid forms. The implications of galactic cannibalism extend beyond individual galaxies. It plays a crucial role in the growth and development of galaxy clusters, the largest structures in the universe. These clusters are held together by the gravitational pull of their most massive galaxies, which often grow by consuming smaller neighbors. This process helps explain why some galaxies become so enormous while others remain relatively small. It also provides clues about the distribution of dark matter, as the gravitational interactions during these mergers reveal the invisible scaffolding that holds galaxies together. As we observe these cosmic feasts, we're reminded of the dynamic and ever-changing nature of the universe. Galactic cannibalism is a testament to the power of gravity and the relentless forces that shape the cosmos. It's a process that has been occurring since the early days of the universe and will continue long into the future. What does this mean for the fate of our own galaxy? As the Milky Way continues its dance with Andromeda, could we too become part of a larger, merged galaxy one day? These questions remind us that the universe is a place of constant transformation, where even the mightiest galaxies are not immune to the forces of change. And with that, we move on to the next mystery in our exploration of unexplained space anomalies. Now, let's shift our gaze to one of the most energetic and enigmatic phenomena in the universe: quasars. These distant objects are among the brightest and most powerful sources of energy ever observed, yet their true nature remains shrouded in mystery. Imagine a single object so luminous that it outshines an entire galaxy, emitting energy equivalent to trillions of stars. That's the staggering power of a quasar. Quasars, short for quasi-stellar radio sources, were first discovered in the 1960s. At the time, astronomers were puzzled by these point-like objects that appeared similar to stars but emitted enormous amounts of radio waves. Further observations revealed that quasars are not stars at all, but the incredibly bright cores of distant galaxies, powered by supermassive black holes. As matter falls into these black holes, it forms a swirling disk of gas and dust, heating up to extreme temperatures and releasing vast amounts of energy across the electromagnetic spectrum. This process makes quasars visible across billions of light years, acting as cosmic beacons in the far reaches of the universe. What makes quasars truly fascinating is their sheer energy output. A single quasar can emit thousands of times more energy than an entire galaxy like the Milky Way. This energy isn't just limited to light, it includes powerful jets of particles that shoot out at nearly the speed of light, extending far beyond the host galaxy. These jets can stretch for millions of light years, carving out vast structures in the intergalactic medium and influencing the evolution of the surrounding cosmos. Despite their brilliance, quasars are not easy to study. They are found only in the distant universe, meaning we see them as they were billions of years ago. This makes them invaluable tools for understanding the early universe, offering a glimpse into a time when galaxies were young and the cosmos was far more chaotic. Quasars also provide clues about the growth of supermassive black holes, which are thought to reside at the center of most, if not all, large galaxies. By studying quasars, astronomers can piece together how these black holes formed and how they shaped the galaxies around them. Yet, many questions about quasars remain unanswered. Why do some supermassive black holes become quasars while others remain relatively quiet? What triggers the immense bursts of energy that make quasars so luminous, and how do these objects influence the large-scale structure of the universe? These mysteries continue to challenge our understanding of the cosmos, reminding us that even the brightest objects in the universe can hold secrets waiting to be uncovered. As we ponder the enigma of quasars, we're reminded of the dynamic and ever-changing nature of the universe. These cosmic powerhouses not only illuminate the distant reaches of space, but also challenge us to rethink our understanding of black holes, galaxies, and the forces that shape the cosmos. And with that, we move on to our next anomaly, where we'll explore the strange and sudden changes observed in neutron stars. Now, let's turn our attention to another cosmic puzzle: neutron stars and their mysterious glitches. These dense remnants of massive stars, often no larger than a city, pack the mass of our Sun into a sphere just a few miles across. But what makes neutron stars truly fascinating are the sudden, unexpected changes in their rotation, known as glitches. Imagine a spinning top that suddenly speeds up or slows down without warning. That's the kind of bizarre behavior we're talking about. Neutron stars are born from the explosive deaths of massive stars in supernova. After the explosion, the core collapses under its own gravity, crushing protons and electrons together to form neutrons. The result is an incredibly dense object with a surface so strong that a sugar cube-sized piece of it would weigh billions of tons on Earth. These stars spin rapidly, some completing hundreds of rotations every second, and they emit beams of radiation that sweep across space like cosmic lighthouses. This makes them observable as pulsars, with their regular pulses of light serving as precise cosmic clocks. But sometimes these cosmic clocks don't tick as expected. Neutron stars occasionally experience glitches, sudden changes in their rotation speed. These glitches can cause a star to spin faster or slower, often in a fraction of a second. For example, a neutron star spinning 100 times per second might suddenly speed up to 101 rotations per second. These events are not just minor hiccups. They can release enormous amounts of energy, equivalent to the power of thousands of nuclear bombs. So, what causes these glitches? Scientists have proposed several theories, but the exact mechanism remains a mystery. One leading idea involves the superfluid interior of neutron stars. Beneath the solid crust lies a sea of neutrons that can flow without friction, behaving like a superfluid. When the crust and the interior rotate at slightly different speeds, the superfluid can transfer angular momentum to the crust, causing a sudden change in rotation. Another theory suggests that starquakes, cracks in the neutron star's crust, could release built-up stress, altering the star's spin. Despite decades of observation, neutron star glitches continue to baffle astronomers. Why do some neutron stars glitch frequently while others remain stable? What triggers these events, and how do they affect the star's long-term evolution? These questions push the boundaries of our understanding of matter under extreme conditions, offering a unique window into the physics of the universe's most extreme environments. As we explore these strange phenomena, we're reminded of the dynamic and unpredictable nature of the cosmos. Neutron stars, with their glitches and quirks, challenge our understanding of physics and remind us that even the most well-studied objects in the universe can still surprise us. And with that, we move on to our final anomaly, where we'll delve into the mystery of ultra-high-energy cosmic rays and their elusive origins. Now, let's shift our gaze to the final enigma on our list: the mystery of ultra-high-energy cosmic rays. These are not your ordinary cosmic rays. We're talking about particles hurtling through space with energies so immense that they defy our current understanding of physics. To put it into perspective, a single ultra-high-energy cosmic ray can carry as much energy as a well-thrown baseball, all packed into a single subatomic particle. Yet, despite decades of research, their origins remain one of the most elusive puzzles in astrophysics. Cosmic rays are high-energy particles, mostly protons or atomic nuclei, that travel through space at nearly the speed of light. They constantly bombard Earth, but most of them are relatively low energy and come from sources like the Sun or other stars. Ultra-high-energy cosmic rays, however, are in a league of their own. These particles are millions of times more energetic than anything produced in human-made particle accelerators, like the Large Hadron Collider. The sheer power of these particles raises a critical question: what cosmic event could possibly generate such extreme energies? One of the biggest challenges in solving this mystery is pinpointing where these rays come from. Unlike light, cosmic rays are charged particles, which means they're deflected by magnetic fields as they travel through space. By the time they reach Earth, their paths are so scrambled that tracing them back to their source is nearly impossible. Imagine trying to follow a single raindrop in a storm. It's that level of complexity. Despite this, scientists have developed ingenious methods to detect these particles, using vast arrays of detectors spread across the globe, like the Pierre Auger Observatory in Argentina. So, what are the leading theories about their origins? Some researchers believe these ultra-high-energy cosmic rays could come from the most violent events in the universe, such as supermassive black holes at the centers of galaxies or the explosive deaths of massive stars in hypernova. Others speculate that they might be linked to exotic phenomena like cosmic strings or even the decay of hypothetical particles left over from the Big Bang. Yet, none of these explanations fully account for the extreme energies observed, leaving scientists with more questions than answers. The mystery of ultra-high-energy cosmic rays is more than just a scientific curiosity. It's a window into the most extreme processes in the universe. Understanding where these particles come from could reveal new insights into the nature of matter, energy, and the fundamental laws of physics. As we wrap up our exploration of these 25 unexplained space anomalies, we're reminded that the universe is full of wonders that continue to challenge and inspire us. Each mystery we uncover brings us one step closer to understanding the cosmos, but it also reminds us how much we have yet to learn. And with that, we conclude our journey through the enigmatic and awe-inspiring anomalies of space. As we step back and look at the bigger picture, one question lingers: could these 25 unexplained space anomalies be connected in ways we haven't yet imagined? While each mystery stands on its own, there's a tantalizing possibility that they might be pieces of a much larger cosmic puzzle. Let's explore whether these anomalies could hint at deeper, undiscovered phenomena shaping the universe. Take, for example, the WOW signal and fast radio bursts. Both involve mysterious signals from deep space, but while the WOW signal remains a one-time event, fast radio bursts are recurring, yet equally enigmatic. Could they both be the result of similar cosmic processes, like the activity of neutron stars or even advanced extraterrestrial technology? The similarities in their unexplained nature suggest that there might be a common thread waiting to be unraveled. Then there's the Great Attractor and dark flow. Both anomalies involve mysterious forces pulling galaxies in unexpected directions. Could the Great Attractor, with its immense gravitational pull, be influencing the dark flow phenomenon? Or could both be driven by something even more profound, like the presence of massive structures beyond our observable universe? These questions hint at the possibility that what we're seeing are not isolated events, but interconnected phenomena pointing to a deeper cosmic order. Consider the Black Knight satellite and Oumuamua. Both have sparked theories about extraterrestrial origins, but could they also be linked to the broader mystery of dark matter? If dark matter makes up a significant portion of the universe's mass, could it be influencing the behavior of objects like these, or even serving as a medium for advanced alien technology? The overlap between these anomalies and the dark matter enigma suggests that solving one mystery might shed light on the others. Even the Pioneer Anomaly and the Moon's Transient Lunar Phenomena, seemingly unrelated, might share a connection through the influence of unknown gravitational or electromagnetic forces. Could there be a hidden layer of physics at play, one that we're only beginning to glimpse through these anomalies? The idea that these phenomena might be linked opens up exciting possibilities for future discoveries. As we reflect on these connections, it's clear that the universe is far more complex and interconnected than we once thought. Each anomaly challenges our understanding and pushes us to think beyond the boundaries of current science. While we don't yet have definitive answers, the pursuit of these mysteries reminds us that the cosmos is full of surprises, waiting to reveal its secrets to those who dare to ask the right questions. And with that, we close this chapter, but the journey of discovery is far from over. As we bring our journey through these 25 unexplained space anomalies to a close, it's impossible not to feel a sense of awe at the vast mysteries that still surround us. From the enigmatic wow signal to the puzzling behavior of the Great Attractor, each anomaly challenges our understanding of the universe and pushes the boundaries of human knowledge. These mysteries remind us that, despite our advancements, the cosmos remains a place of endless wonder and unanswered questions. What makes these anomalies so significant is not just their strangeness, but what they represent: opportunities for discovery. They invite us to question, to explore, and to imagine possibilities beyond our current understanding. Whether it's the possibility of extraterrestrial life, the existence of unknown forces, or the hidden workings of dark matter and dark energy, these anomalies are windows into the deeper truths of the universe. As we reflect on these mysteries, one thing becomes clear: the universe is far more complex and interconnected than we once thought. Each anomaly, whether it's the Black Knight satellite or the cosmic microwave background cold spot, offers a piece of a puzzle that we're only beginning to assemble. And while we may not have all the answers yet, the pursuit of these questions is what drives science forward. So, what do you think? Could these anomalies be connected in ways we haven't yet imagined? Do they hint at a larger cosmic story waiting to be uncovered? We'd love to hear your thoughts and theories in the comments below. Don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an update on the latest mysteries of the universe. The cosmos is full of surprises, and together we can continue to explore its secrets. Until next time, keep looking up.